Once the design has been finalized, I can then go to step 6 and evaluate the properties of the design. The wizard provides a number of different numerical and graphical summaries which give me important information about the design I've selected. Of particular importance is something called the predictive variance, which quantifies how well I'll be able to predict the response throughout the experimental region. If the design is a good one, this predictive variance should be relatively constant throughout the entire experimental region. To evaluate the properties of the design, I'm going to press the button labeled Step 6 on the toolbar. This will bring up a dialog box listing various tables and graphs that can be used to evaluate the experiment I've created. The output I'm interested in here is the leverage and the prediction variance plot. When I press OK, this will add a table and a graph to the main wizard window. Double-clicking in the bottom left, you can see the leverage. Leverage is a statistic that measures how much influence each of the runs in the experiment has on the estimated model. Ideally, every experiment will contribute an equal amount of information. They're not all exactly equal, but you can see that they're all fairly close to each other, meaning that no one result will have a dominant influence on the fitted mathematical models. Looking at the prediction variance plot, you can see the standard error of the predicted response by looking at the height of the surface. Here it's plotted over the space of temperature and time, and you can see that actually the standard error is quite constant throughout that entire experimental region. That's good. I'd be unhappy, for example, if in some areas of the experimental region I got a much poorer estimate of the response than in others. Ideally, something like you see is what we're aiming for.